Alright, so today we're going to talk about equations that contain a rational exponent and how to solve them. Okay, so these are actually really good steps that you should be familiar with by the end of this lesson. First, we're going to always try to isolate the term containing the rational exponent. Remember, rational just means a fraction, and exponent means power. So something like this would be a rational exponent right there, that 4/3. Alright, step number 2 would be to raise both sides to a power that is a reciprocal of the power in the problem. Then we're going to solve for x, then we're going to check for extraneous solutions, and then we're going to write the solution afterwards. Alright, so I know you probably are not familiar with what that means. So what we're going to do is we're going to go ahead and do a few of these so you can kind of become more familiar with how to work these out. Okay, so alright, so on this part right here, the term with a rational exponent is already isolated. Alright, so if it's already isolated, then all you have to do, I'm going to rewrite it here. This is 4/3 equals 16. Alright, we're going to raise both powers, we're going to raise both sides to the reciprocal power. Alright, so if this power is 4/3, we're going to raise this to the 3/4 power. And we're going to do it to both sides. We're going to do it to this side, to the left side, we're going to do it to the right side. Okay, so now, this right here, this is going to cancel. Now, before I just said, well, this is going to cancel, remember, when you have a power to a power, you multiply those powers. So if you multiply 4/3 times 3/4, that's actually 1. So essentially what really happened is that this is to the power of 1, and next to the power of 1 is just x. Alright, now on this side, we're going to write this as the 4th root of 16, and then we're going to raise that to the 3rd power. Okay? Now, what's going to happen after the fact is that we're going to go ahead and we're going to take the 4th root of 16. Now, the 4th root of 16 is actually plus or minus 2, believe it or not. Alright, it's just like a square root, if you will, right? If I take the square root of 16, then I would get plus or minus 4. Same idea. So now we're going to get a 3 here. We're going to then cube that. So in this one, we're going to have two answers. One of them is a positive 8, and one of them is a negative 8. The next step after that is that you should check out your solution that you just got to see if they both work. Okay, so I can come over here and I can put negative 8. Make sure you put that in parentheses. We're going to raise that to the 4/3 power. And if that gives me 16, then that's a solution. Okay, so that's a valid solution. Same idea, we're going to check that but without the negative. So we're going to check the positive of that. We're going to raise that to the 4/3. I'll also get 16. So both of these are solutions to the equation. Alright. So one thing to note here, right, you're going to notice later, is that if I take a square root, alright, or any even root, I will have a positive and a negative answer. But if I take a root that's an odd root, like a cube root, 5th root, a 7th root, all of those only have one answer. Right? So they either have a positive or a negative, but not both. Alright, so let's go on to number 2. So on number 2, we're going to try to isolate the term containing the rational exponent. So we're trying to get this by itself. Alright, so just focus on getting rid of everything else. So this x, we're going to subtract it. So we have 3x to the 1/2 power is equal to negative 6, and then now we're going to raise this to the reciprocal power. The reciprocal power of 1/2 is 2/1, or just 2. Right, so 2/1, that will cancel that, so I would end up with 3x. And then negative 6 squared is positive 36. So this is x is equal to 12. Okay. Now, I need to see if this works. And let's see if it does. Right, I'm going to plug in this 12 right here. So again, you can use a calculator if you like. So I have parentheses 3 times 12 to the power of 1 divided by 2, which is actually a square root, and plus 6. Now that should give me 0. So what they expect out of here is to get a negative number. But it does not. That gives you 12, which is not 0. So the only solution you have here is actually not a solution at all. Alright, so there's actually no solution to this one. This is what's called an extraneous solution. Okay, sometimes that happens. Alright, let's go over to number 3. Now on number 3, same idea, we're going to try to isolate the term that has a rational exponent first. Alright, so remember, this is the term that has a rational exponent. So everything else, the 1 and that negative 3, I need to get rid of it. So we're going to start off by subtracting 1. So we have negative 3, 2x minus 1 to the power of 3 halves is equal to negative 24. And I'm gonna get rid of this negative 3 also. Alright, so I'm going to go ahead and divide this by negative 3, divide this by negative 3, so I get 2x minus 1 to the power of 3 halves is equal to 8. Alright, so now that I have that term isolated, my next thing to do, my next step is to raise this to the reciprocal power. Right, the reciprocal power in this case would be 2/3. So I'm going to raise this to the 2/3 power. So this is going to give me 2x minus 1, right, because the 3 halves times 2/3 is 1. So this would be all of this to the first power, which is just itself, right? And now 8 to the 2/3, what we have, this is the same thing as having the cube root of 8 squared. Right, the cube root of 8 is 2, and 2 squared is 4. Alright, so we're going to add the 1. Excuse me, sorry about that. We're going to add the 1 and divide by 2. So this is going to give us 2x is equal to 5. So x is equal to 5 over 2. And then now our job would be to take that solution we found, and let's make sure that it's not an extraneous solution. So now I'm going to show you a quick trick here. If you have 5 halves, alright, so I'm going to put 5 halves is 2.5. So if you don't believe me, just do it on the calculator. So we can put a 2.5 there, and then we're going to press this store key, which is this STO key by this 4. And then we're going to type in an x, which is this one. Now if I enter, from now on the calculator thinks that x is equal to 2.5. So this is going to be a much faster way to check some stuff, okay? So we have negative 3. So now I'm just going to type it in exactly like this. 2x minus 1 to the power of 3 halves plus 1. And that should give us a negative 23. And it does, so therefore this is a legitimate solution. So x is equal to 5 over 2. Alright. Now number 4, same idea. Let's see. I'm going to go ahead and leave that one up to you. See if you can do it. I'm going to go ahead and tell you that the answer is 64. And let's see if you can get that. Okay, so try that one out on your own. See what happens. Okay. Now we're going to go over steps for solving radical equations. Now, it turns out that a radical equation and a rational exponent, they're the same thing. Okay, so the steps are very similar. Alright, so again, we want to isolate the term with a radical. Now this is the radical, which is that little square root sign, right, that you're familiar with. This is already by itself, so I don't need to do anything with that yet. Now I'm going to get rid of that, and the way that I get rid of that is I'm going to raise this to the power of 2, because this is square root. So the opposite of the square root is squaring. Right, so I'm going to square both sides, and that's going to give me, that's going to get rid of the square root sign. That's going to give me 25, and I'm just going to solve for x at this point. Alright, so we're going to add 18. See if I add 18 to each side, I get 7x is equal to 43. I want to divide by 7. So I get x is equal to 43 over 7. Alright, so that's what I got. Now again, just like before, you need to check for extraneous solutions. So again, let's go over that step one more time. Now 43 over 7, let's see, 43 divided by 7. I'm going to store that. I'm going to come over here and press this STO key as x. And from now on, it thinks that x is this number right here. I'm going to plug that in now. So I have the square root of 7x minus 18, and that has to be equal to 5. Okay, so this one's equal to 5, so this solution works. So this solution works. Alright, let's move on to number 2. Again, steps are very similar to the rational exponents. I want to isolate the radical, which means this, right? So I'm going to subtract the 1 from both sides. So this is going to give us 3x minus 8 square root is equal to 2, and then now I'm going to square both sides. So once the radical is isolated, you're going to get rid of it by raising it to the power of 2 in this case, because this is square root. This is going to be 4. This is 3x is equal to 12 if I add the 8 to both sides, so x is equal to 4. Now, if you check this, it should give you 3, and for the sake of time, it does give you 3, right? So make sure you check all your solutions, but this one will work. All right, let's go to number 3. Now, number 3, again, remember, we're trying to isolate the radical, which is that. All right, now this one's a cube root, so it's going to work essentially different, but we're still going to isolate it, so that step is the same. So we're going to add the 24. So we have 8 cube root of x is equal to 24, and then now we're going to divide by 8. Again, I want to isolate that radical term. So this one is going to be 3 here. Yeah. And then we're going to have to get rid of the cube root. Well, very simply, we're going to raise this to the third power. To get rid of a cube root, we raise to the third power, so this would be 27. Alright, and if you plug it in here, that actually does work, so make sure you use your calculator, plug it in, make sure that it works. Okay? Now, on number 4, okay, you're going to get, let's see, let's just start off. Isolate the radical, so we're going to try to isolate this guy over here. So we're going to subtract 7, I get 4. Square root of x is equal to negative 4. We'll divide both sides by 4. So I get x is equal to negative 1. We're going to square both sides. That will give us x is equal to 1. Now, if you plug that in, I'm actually going to do this by hand. If we plug that in over here, a 1, I'm asking you, is that equal to 3? Alright, so this is the square root of 1 is just 1. So this is just 1. 1 times 4 is 4. And you can tell that this is definitely not going to be equal to 3. It's not. So it's actually, this solution does not work. So there is no solution. Okay. So let's go ahead and move on to the back. There are some more difficult problems than this in the back. So let's take a look at it. Again, we're still going with getting rid of the radical. So that step, all the steps are going to be the same, but sometimes the difficulty, like you're going to see on number 5, is definitely going to be higher than the ones I've done so far. Right? So again, isolate the radical. Just focus on that. We're going to subtract the 5. So we have the square root of x plus 7 is equal to x minus 5. Now, again, focus on the radical. How do I get rid of the radical? It's by itself now, so I'm going to go ahead and square. Square here, square here. That's going to give me x plus 7. That's going to get rid of the radical. Now this right here, now this, if I square this, remember x minus 5 squared is the same thing as multiplying x minus 5 times x minus 5, which means you have to FOIL. And if you FOIL, you would get x squared minus 10x plus 25. And so that's what you would get if you FOIL. Alright, now the next thing to do is basically how do I solve for x now? Right? And if I have a quadratic equation like this, what I have to do is set this equation equal to 0 first. So I'm going to move this x and this 7, this x and this 7 to the other side, and now I have x squared minus 11x plus 18 is equal to 0. And then now I have to go ahead and try to factor this or use the quadratic formula to solve for this. Luckily for me, this is factorable. Factors of 18 that up to 11 is 9 and 2. So this will give me two answers. Remember, you set each factor equal to 0, and then you solve for x. All right, so if you thought the factoring was gone, surprise, it's not. Alright, so now this one you have two answers. Now this is really when knowing that trick on this calculator really pays off. So again, I'm going to try one at a time. So I'm going to put 9. I'm going to press this store key, which is right here. And I'm going to put an X. And now I'm just going to plug this equation. So 5 plus the square root of x plus 7. And that has to give me basically what x is, which in this case is 9. So that gave me 9, so that one works. So in order for me to do this again, now I'm going to store 2 as x. Okay, so now I'm going to go back over here. I'm just going to press the directional button up, highlight that equation, and then I'm just going to press enter. Now that should be equal to 2. Remember, because this equation, right, that's x, and this equation. So if x is 2, that also should be 2. So 2 does not work. That's what I'm getting at. Okay, so 2 does not work. So the only solution to this one is x is equal to 9. Alright, let's go ahead and move on to number 6. Again, same idea. We're going to try to isolate the radical. We're going to start off by adding x to this side. So I'm going to end up with 3 square root of x plus 1 is equal to x plus 1 here. Alright, so here's the deal. Alright, yes, you can divide both sides by 3, and if you do, you would end up, I'm going to put it up here because I'm actually not going to do that, and I'll show you why here in a minute. You would end up with x plus 1 over 3, and then you would have to square both sides. So if you want to do it like that, there's really nothing wrong with doing it like that. Okay, so you can do it like that, and then you would get a 9 on the bottom, and then you're stuck. Alright, not stuck, but it's definitely more difficult. So just because I've done this over time, I know that if I leave that 3 over here, it'll be better for me, which is, I know is counterintuitive, or is kind of against what I've said earlier, right, to isolate the radical, but trust me. So we're going to go ahead and square all of this, and we're going to square all of this. And I'm going to show you how you would end up with the same thing, no matter how you did it. This would be 9x plus 1. Right, so that square that 3, and when I square this, I just get that. We're going to FOIL this, so I get this. Alright, so by the way, here's what would happen if you did this on this one, alright? You would have x plus 1. I just want to show that it is the same thing. You have x squared plus 2x plus 1, all of that over 9. That's what would happen if you square that. And to make this easier for you, because otherwise it's going to kind of be kind of a nightmare, I would have to then multiply both sides times 9. So basically I would end up here again. Okay, so that's what you want to leave that alone. Anyways, but that comes with practice. So if you do it wrong the first time, it'll be alright. You can get to the answer eventually. Right, now just like the problem before, I want to set this equal to 0, so I'm going to have x squared. I'm going to subtract the 9x, so I have negative 7x. I'm going to subtract the 9, which is negative 8 now. Alright, so again, I subtracted those two from here and here. And then I'm going to factor. Alright, on this one, if you check both answers, they do work. So I've checked this ahead of time, so make sure to check your answers. Alright, so on number 7 looks really hard, but it's actually one of the easiest ones you can do. You have a radical here and a radical here, great, and nothing else. They're just radicals by themselves. So what you do on these is you're going to square both sides. If I square both sides to get rid of the radical, well, I end up just with the inside. So see, two linear functions, not too bad. Get all the x's on one side, so I'm going to subtract x. So this is 2x plus 1 is equal to 15. I'm going to subtract the 1, so I get 2x is equal to 14. So x is equal to 7. Okay? And if you do check that, remember on that one you would have to plug in a 7 here and a 7 here and make sure you get the same number, and you do on that. Alright. Now, number 8 stinks. I want to go ahead and tell you that. Number 8 is not too nice. So here's the deal. On this one you have two radicals and then you have a number besides that, right? You have a number right here. So the thing you want to do is you want to leave one radical on one side. And you want to move this other radical, this one right here, to the other side by adding. So I'm going to add all of this to the right side. So I have x minus 2 plus 1. So these are like the hardest problems you can do on this type of homework, right? So now what we're going to do here is we're going to try to get rid of the square roots. Now in this one, I've done all I could. I can't really isolate those radicals anymore. They are what they are, okay? So to get rid of it, I'm going to have to square both sides, which really stinks for you, because what that means is you're going to have to foil. You're going to have to foil this right here. Alright, so I'm going to actually write it completely out so you can see it and don't freak out. Alright, so remember that this right here would be x minus 1 plus 1 I got a little small there. That one's kind of hard to see, so I'm going to go ahead and rewrite that. Alright, so we have an x minus 2, right? So essentially we're multiplying this times this. So let's do it one at a time. The square root of x minus 2 times the square root of x minus 2, the square roots would cancel, and I end up just with x minus 2. Alright? Now the middle term would be the square root of x minus 2 times 1, which would be x minus 2. Okay, well that's not too bad. And then now we're going to multiply this times this. So 1 times this gives you again x minus 2, like that. Finally, you have 1 times 1, which is 1. Alright, we're going to add like terms. So if we can, notice that this right here, these two are like terms. So we're going to add those two. So we have x plus 3 is equal to, also I think there's another like term. Where is it? Let's see, we have a, and then we have this like term, yes. So we're going to add those two. So we're going to end up with x minus 1 plus 2 square roots of x minus 2. Now remember, this 2 came from adding those two. If I add those two right here, it becomes this. And those two circles became this. Alright, negative 2 plus 1, negative 1. Alright. So now you're probably thinking, what do I do with this? Well, now we're back to what we were doing before. We're going to have to isolate the radical. Alright, so we're going to try to get the radical by itself. So, remember, do not add this negative 1 and 2. This 2 is attached to this, alright? Remember that. So we're going to go ahead and try to get this by itself. So I'm going to add or subtract both of these to this side. I'm going to subtract x, add 1. Bye-bye. Negative x. I'm going to add a 1. Notice that, luckily for us, those x's cancel. So we end up with 4 is equal to 2 square roots of x minus 2. Now we're going to divide. Alright, so now we have the radical by itself. So we did all that just to isolate the radical. Go figure. Alright, so now we're going to go ahead and square both sides. So I have a 4 is equal to x minus 2. Again, I just square both sides. So x minus 2 is equal to 4. which means that x is equal to 6. And if you plug that 6 over here, it does work out. All right, so now we're going to do one more. I'm going to see which one looks the worst. Let's see. Yeah, let's do this one right here. Kind of same idea, essentially. All right. Yeah. So these two are the same idea, but I'm doing number 10 for the sake of time, so hopefully you're still here. All right. If you need a break to check your Instagram, go ahead. Check your Snapchat, sure. Right, so again, right here I want to add this to this side. Okay, so I'm actually going to stop right here, and I'm going to record this one on another video just to save you some time and some effort, okay?